Okay, we're recording. So if you're not here, sorry, right? You missed out on all the cool stuff that we've done already before we started the lesson. I even passed out a 10-pound bag of $100 bills, and I just let everyone who was here just take a handful out of the bag and pass it around. So sorry if you're not here. If you're listening on the video, good. At least you're taking care of business, watching the video like you should. But if you want to grab money, you're going to have to raid your parents' wallet, I guess, because all the money's gone. Oh, I thought it was a gold nugget on the ground. All kinds of cool things happening today. Let's look at example 9. Algebraically find all ALL solutions to this. So when we say all solutions, that means, first of all, it's conditional. And the way that we're going to list all the solutions is going to be more like what we did up here, okay? Where we're going to find all of the ones in our comfort zone, which is between 0 and 2 pi. We can find all of those, and then we know how often all the others occur, which is not always 2 pi, right? Because we can stretch and compress horizontally to affect the period. But if we can find all the ones within one rotation, whatever the rotational cycle is, we can just add multiples of the full rotation. That's how you list all of them, right? So let's go ahead and look at number 9. Find all the solutions. Okay, so square root of 2 tangent of x times cosine of x equals tangent of x. Okay, so would this be a good first move to divide both sides by tangent of x? Because look, divides out there, divides out there. Is that a good move? No, why not? Oh, well, yeah, it's actually just one of 3 factors. So I can actually divide through by any one of those. So yeah, I can separate that. But if I divide both sides by tangent, where did it go? Is it still in the equation somewhere? I lose information, right? You lose information. So you don't want to do that. Now, if you wanted to, watch this. You could divide both sides by cosine because it does divide out here, but does it divide out on the other side? No. So the information is preserved. So it's not illegal to divide through by variables, but if it's gone on both sides, then that's not good. So the way we want to do something like this is quite simple, right? If you have more than one variable term, and we do, we have one on the left, one on the right, you want to get everything on one side, and you set it equal to 0, right? So we got the square root of 2, tangent of x, cosine of x, minus tangent of x, and we set it equal to 0. And of course, once it's equal to 0, our next goal is to do what? Factor. That's right. And the first rule of factoring is to pull out a common factor. So I spy the tangent of x in both of them, right? A common factor other than 1, right? If the leading coefficient were negative, we'd want to factor it out, but it's positive square root 2. So let's factor out a tangent. So we divide it out, but we put it in the front. We don't divide it out on both sides. Factor it out, but leave it visible. And we're left with the square root of 2 cosine of x minus what? When we factor it out of itself, don't forget your x. 1, good. Don't put 0 there, it's 1. Okay, and I know it's easy to leave off the angle, the x, behind the trig function, but you'll lose a point on ultimately when we test over this. There won't be any multiple choice. So I'll be grading your work. So make sure you have it. All right, and now we can set each factor equal to 0, right? 0 product property, it's called. So tangent of x equals 0, or square root of 2 cosine of x minus 1 equals 0. Great, and now we've taken one problem and we've turned it into 2 problems. Great. That's just my luck, right? But is that really a problem? To have 2 problems? No, because each of these 2 problems now is simpler than the one big problem. So it's like divide and conquer, right? It's like, I need to make cookies, but I don't know how to make cookies. That's the problem. But then you break it down into like, first of all, I need to get an oven, right? And then I need some milk. And then, of course, I never have eggs, right? Individual problems, which are all easier to solve, right? That was a horrible analogy. I don't know why I said that, but you get the idea. All right, so now let's find all of the solutions between 0 and 2 pi first. All right, I'll do it like this, like I did yesterday in class. 0 to 2 pi colon. It's unit circle time, everybody. but we got to use it in reverse. So you don't have to take the inverse tangent of both sides to solve for x. You can, but it's not going to be the inverse tangent function. It's the inverse tangent operation. So I like to just leave it like this: tangent of x equals 0. And then I ask myself, tangent of what angle is 0? Where was tangent 0 on the unit circle? At 0. And was that the only one? Pi? Yeah, pi. Good. Y'all said pi. And then also going all the way around to 2 pi, right? Yeah. Good. Because tangent is y over x. So tangent 0 and y is 0, and y is 0 on the x-axis. Good. And then we'll come over here to this other one. Or if I solve this, I add 1 to both sides and divide by the square root of 2. That's cosine of x equals 1 over the square root of 2. Ooh, is that a unit circle ratio for cosine? Exactly. That's right. If we rationalize that, we get the familiar square root of 2 over 2. Yes. And so if you're ever solving problems like this and it's a non-calculator, which it won't be, it's going to be something that I'm expecting you to remember from the unit circle. Okay, now I'm not going to take the inverse cosine of both sides. I'm just going to say, what are the two angles where cosine was positive square root of 2 over 2? If you need to draw it, it should be here. And all the way around, it should be here, right? Oh, we just rationalized it. I multiplied by the square root of 2 over the square root of 2. Yeah, okay. Good. So what's the reference angle where the x coordinate is root 2 over 2? Pi 6, pi thirds, or pi fourths? Pi fourths, good. So the one in quadrant 1 should be just pi fourths. And then the one in quadrant 4, we're not in the PVR anymore, so we're not going to go negative pi fourths. We go all the way around to 7 pi fourths, okay? So now we have, what, 5 solutions within one rotation? I guess technically 2 pi is the next rotation. And do any of those cause a 0 in the denominator? Well, no, we don't really have a denominator, do we? So I know tangent doesn't have a domain of all real numbers, but we actually solved the tangent equation. So these aren't going to be undefined. So these all work. If you plug them in, you don't get division by 0. So now how do we list all of them? Well, 0 is coterminal with 2 pi, right? I know that. Like 2 pi is really the start of the next rotation. So really, I have 0, pi, pi fourths, and 7 pi fourths, plus all of their coterminal angles. So here's the solution set, right? So x is going to equal to 0 plus 2 pi n. X is going to equal to pi plus 2 pi n. X is going to equal to pi fourths plus 2 pi n. And x is going to equal 7 pi fourths plus 2 pi n. And then we'll just say one time where n is an integer. All right, so we don't need to list the 2 pi because that's just coterminal with the first one. When n is 1, I get 2 pi. Now, notice that pi fourths and 7 pi fourths, they're not coterminal with each other, are they? They're not evenly spaced from each other. Okay? If you look at the spacing over here to the right, they're only 90 degrees apart. But if you look over here, they're 270 degrees apart. So we actually need both of those plus their coterminal angles. So what we have over here is fine, but we can actually condense it a little bit, right? Let me show you what I mean. These two have to be pi fourths plus 2 pi n and 7 pi fourths because they're not evenly spaced. But what do we know about the other two, 0 and pi? 0 is here and pi is there. So it's okay to say 0 plus multiples of 2 pi, that get us back over here. And it's okay to say then also pi plus multiples of 2 pi. But aren't 0 and pi evenly spaced from each other? They're exactly pi units apart, right? So if you wanted to, like if this were a multiple choice question, I might consolidate those two into a single one, right? I could write that as what? X equals 0 plus not 2 pi n, but how would I then guarantee that I land on the x-axis every time? Pi n. Very good. 0 plus pi n, or just pi n, right? So you can't always do that, right? You can only do that if they're 180 degrees away from each other. That's it. And sine and cosine aren't always 180 degrees from each other. Now, if you remember, tangent and cotangent are. Tangent and cotangent always live in opposite quadrants, right? 180 degrees. So with tangent, you could do that. But sine is always going to be vertical adjacent. Cosine is always going to be horizontal adjacent. So anyway, there you go. That's all of them, right? That wasn't too bad. Hey, look, speaking of psychology, look at example 10. Happy birthday, Sigmund Freud, 166 years old today, 1856. That was pretty clever of those, right? I threw the math question at him. How old is he if he was born in 1856? Old, yeah? Very good. That's good. Yeah. Look at this. Find all the solutions such that, what the heck is that variable? It's not x anymore. No, theta is the circle with the, yeah. It's psi. Yeah, yeah. There's a clue if you keep reading. Then breathe a sigh of relief, right? Yeah. So this is psi, and it's significant because if you say the word psychology, what sound comes out first? Psi, right? So the American Psychological Association uses that psi letter as its logo. I don't know if you've ever seen it. The APA, as they're called. They use the pitchfork, right? Some people think it's the devil's trident or Neptune's trident. Like, no, it's psi, like in psychology, right? Like the math club uses mu alpha theta. Mu alpha theta. That's math, right? Mu is M, A is alpha, and theta is the TH consonant blend in Greek, theta. So ma, a, right? Greek, right? It's all Greek to me. So anyway, it's psi. So if you don't like psi, you can change it to x, you can change it to theta. It's just another letter that I threw out there. And notice we want the solutions between negative 4 pi and 0. That's 2 negative rotations. Now, when the time comes to actually work this, I'm still going to find the ones between 0 and 2 pi. But then for those, I'm going to go back a rotation to find between negative 2 pi and 0. And I'm going to go back another rotation to find negative 4 pi to negative 2 pi. And then I'll ditch the ones that I started with. I'm always going to use the comfort zone ones from 0 to 2 pi as my starting point. And then I can either add to those or subtract from those and then keep them and get rid of them depending on the interval, okay? And we really don't have time to do this today. So we'll finish this on Monday, and your worksheet is actually going to be due on Tuesday. How about that? And we'll finish this Monday in class. Monday in class. Now, I might be a little nervous Monday while I'm doing this. And you'd be like, Mr. Corby, why are you so nervous? Do you have a bad weekend? I'd be like, no, it's because my BC calculus kids are taking the AP exam right now. And I always get nervous for them. I always do. I know they're going to be well prepared, but, you know, just like a nervous parent, right? Always getting nervous. Get worried for them. Concerned, right? Worry wart. I'm just a worry wart. All right. Any questions? All right. Be groovy. Stay mathy. Have a good, fun, safe, awesome weekend. Stay dry, stay cool, and stay be groovy. Stay groovy and stay mathy. Yeah, there we go. Good message. Good messages. Frosty, stay frosty. Hey, y'all can get an icy if you want. I know it's breakfast, but the scissors are in the ice tray. If you open the freezer, there's popsicles in there. I don't know if you like frozen ice, flavored ice for breakfast, but help yourself. The trash can is right there, and the scissors are in the ice tray. Just cut the top off, and you are good.